So let's move on to question number 4. This is the graph for question number 4. Let's see what it has. It says calculate the velocity of the body as it moves for the time interval 0 to 5 seconds. So basically this is the time interval that we're looking at. You don't need to draw anything on your graph, but this is for our reference because 0 to 5, this is the second. I have also marked what are these coordinates. First thing we write is x-axis. This is 5 on the x-axis, 3 on the y. This is 7 on the x-axis, 3 on y. This is 9 on the x-axis, 7 on y. So calculate the velocity. We know velocity is equal to the slope of the curve. So, and how do I calculate slope? y2 minus y1 upon x2 minus x1. So let's look at part 1 for 0 to 5 seconds. For 0 to 5 seconds, slope will be equal to y2, which is 3, minus 0 upon 5 minus 0, which is equal to 3 upon 5, which is equal to 0.6 meter per second. That's part 1. Part 2, between 5 second to 7 second. Now 5 second to 7 second, which is this curve, I don't even need to calculate since this curve is parallel to the x-axis. I know that the displacement is not happening, which means velocity is equal to 0. In this case, the displacement is not happening at all, which means the object is stationary, which means velocity is 0. Let's go to part 3, between 7 second to 9 second. So this is the curve that we are looking at, 7 second to 9 second. So slope, which defines my velocity, will be equal to y2, in this case 7, which is this, minus y1, which is 3, minus 3 upon x2, which is 9, minus x1, which is 7. So 7 minus 3 is 4, 9 minus 7 is 2, which is equal to 2 meter per second. Now there could be a question, why do I always take this as x2 y2? Why can't I take this as x1 y1? Let's take it as x1 y1 and let's call this x2 y2. Will my slope differ? Let's see. So let's see if I have changed the name. Now y2 is 3 and y1 is 7 and x2 minus x1. So x2 is 7 and x1 is 9. So 3 minus 7 is negative 4. 7 minus 9 is negative 2. The answer is still 2 meter per second. So it does not matter which point I call x1 y1, which point I call x2 y2. Now let's look at part 2 of the question. Average velocity during the time 5 to 9, which means between these two time periods. So average velocity is given by total displacement upon total time. Now since it's between 5 second to 9 second, I know my time is 4 second, and displacement between this time to this time is 7 minus 3, which is 4. So the average velocity is 4 upon 4, which is 1 meter per second. Let me add questions of the second. So I'm on question number 5. So let's see the question. From the displacement time graph of cyclist given, find the average velocity in the first 4 seconds. So I know that the average velocity is equal to total displacement upon total time. So total displacement upon total time in the first 4 seconds, which means the time given is 4 seconds. So let's see the total displacement. This is 4 seconds, which means let's see where this graph meets. This is where the graph meets. So the displacement is 10 seconds, 10 meter. So 10 meter upon 4, which is 2.5 meter per second. Let's see part 2. Displacement from the initial position. So this is my initial position and displacement at the end of 10 seconds. This is 10 seconds. So let me see where this graph goes. This is the point, which means it is at a negative 10. So part 2 is displacement at 10 second is equal to negative 10 meter. What does negative mean? Which means from the original direction it's going in the opposite direction. Let's look at part 3. The time after which he reaches the starting point. So we remember this is the point which is the starting point, this is the point which is the starting point, and this is the point which is the starting point where displacement is 0. So since he's talking about time after which means obviously this is the initial time, which means the time after which he reaches a starting point again is 7 seconds and 13 seconds. So let's look at question number 6. Question 6 says the distance by which the car was initially ahead of car A. So this is car A and this is car B. Car B is 40 kilometers ahead. So the distance by which car B was ahead is 40 kilometers. The velocity of car A and car B. Now we remember the slope of the curve gives me the velocity. So here I am calculating velocity for A. So for A, I have marked the point, this is 280. So for A, it will be 80 minus 0. This is point x2, y2, and this is point x1, y1 for A, upon 2 minus 0, which is 80 upon 2, which is 40 kilometer per hour. Now let's calculate for B. Slope, which is equal to velocity for B, will be equal to, well, again 80 minus, but for B this is x2 y2 and this point is x1 y1, because B is, this is the curve, this is the curve, right? So this is x2 y2 and this is x1 y1. So 80 minus 40 upon 2 minus 0, which is 40 upon 2, which is 20 kilometer per hour. Part 2, the time in which car A catches car B. So this is the time when they catch up, which is 2 hours. So this is 2 hours. The distance from start when the car A will catch car B. This is the distance from start, and how, when do they catch? At 80. So this is, answer is 80 kilometer. Thank you.